A, something like this. So what exactly is determinant? సో గ్రాఫికల్గా మనం ఆలోచిస్తే ఒక పిక్చర్, ఒక బొమ్మ రూపంలో ఆలోచిస్తే వాట్ దట్ పర్టికులర్ మ్యాథమెటికల్ కాన్సెప్ట్స్ ట్రై టు ప్రజెంట్. మనం కొన్ని ఏం చేస్తామంటే జస్ట్ ఈక్వేషన్స్ వేసే క్యాలిక్యులేటర్ వేసి చేసేస్తుంటాం. బట్ ఇన్డెప్త్గా పోతే దే హావ్ గాట్ ఏ వెరీ లూసిడ్, చాలా సింపుల్గా వాటి యొక్క ప్రాముఖ్యత తెలియజేస్తాయి అన్నమాట. వాటిని మనం క్యాచప్ చేయగలిగామంటే యూజువల్గా మ్యాథమెటికల్ సబ్జెక్ట్స్ చాలా ఈజీగా అర్థమవుతాయి. సో దట్ ఈస్ మై ఇంటెన్షన్ హియర్. That is the mathematical animation. Okay, I can thank you for considering this particular lecture. So it will not be heavy, it will not be any mathematical oriented, and the equations same undavu. No programming will be done here, just certain simple thoughts, and after that we will see what we can do. So I think all of you can see my screen.
Yes, sir.
Okay. So today's agenda is first the inspiration. What made me to consider this particular mathematical animation, then installation and software setup, then creating the animations, and then a small demo on how I use this particular software package. Okay. Inspiration came to me while I was learning neural networks. Accidentally, I came across a particular video made by a channel called as 3 blue 1 brown, 3B 1B. As you can see on the top here, 3 blue 1 brown. The name of the channel is there. And I'm amazed at the accuracy, the clear-cut presentation of the concepts that are happening in the neural network. Then I explored some other videos, and I saw that this particular channel is giving mathematics in such a simple, lucid way that I'm simply amazed. Then I research something more about as to how that particular person actually made those particular videos. Then I googled it out and I came upon a particular Python library by name M-A-M-Anim. M standing maybe for mathematics or mathematical. Anim may be standing for animation. They named it like that, mathematical animation. And that's my inspiration. So I tried to download all the relevant software. I had set up my own instrument, that is my own laptop, to run that particular software. And past 2 weeks, I was doing, or I was experimenting on that, and I could write a very simple, humble animation to demonstrate a simple concept in engineering mechanics. Dani nidivi, video time is 1 minute, 1 minute 13 seconds. I could do that. So first I had some difficulty to synchronize or unify all the packages. There was a lot of difficulty. Something is not working, then learning something about the package. And later once I got the nerve of that particular package, now I thought it's a simple one and easy terms. And I thought that I share my experience with you, and you may be benefited with that particular experience. So what exactly is Manim? Manim is a Python library. So if you are conversant with Python programming, it's easy. And as you know, Python is now ported to almost all OS operating systems, from Windows to Linux to Unix to Mac and OS. So whatever operating system you take, this particular Python runs on that particular operating system. So Python is almost now universal, and it has got a very beautiful, very strong, very coherent, and very agile the module system, that is package system. I think you must have heard one word like, say, PIP. PIP is a module maintenance software for Python. So using that particular PIP, we can install so many packages or modules that we need. This particular package or the module is very precise, very sharp pictures we can create, and it is very powerful, and it has got a very tremendous mathematical computing facility. And using this particular software or the library, we can create animation videos, or we can create GIFs, or we can grab the still images also, which are very sharp. So that's the software. That's a package. It's not exactly a software. It is a package of Python that we can do for the special purpose of creating the mathematical animations. Okay, and by the way, if you got any queries or if you want to ask anything, you can interrupt me. You can unmute your device and ask me. If possible, I will answer your questions. Please feel free to interact with me. It's not a regular lecture where strict rules are followed. It is not like that. You are free to kick in at any point of time. Then, as far as the installation is concerned, it requires certain prerequisites. So there is a software called FFmpeg. Remember, all the software is free, including the prerequisites. So we need not pay a single pie to acquire the whatever software that we need. And there are no issues with licensing. So you are free to experiment with all these things. You are given the complete freedom. But there may be some troubles and some nuisances that come up with any open software. But remember, this is complete free, complete open source software. No licensing is required. The first prerequisite is FFmpeg. I have written the web address also. If you want, you can grab the screenshot, or I will, if you want, I will share the presentation also later to Venkat Narayan sir. From Venkat Narayan sir, you can take it out. Then, if you want to work with or do some animation with differential equations or integral equations, then you require a special package called as LaTeX, and that LaTeX is required if mathematical equations, including differential equations, and then certain typesetting, special typesetting apart from the normal text is required, then only we require that one. Otherwise, it is not required. Only FFmpeg would be sufficient. For full installation, you can, with LaTeX, you can consider three subvarieties. One is called as MikTeX and TeXlive and TinyTeX. Just understand me or believe me that I could not succeed in installing the MikTeX and TeXlive. So till now, I didn't succeed that way. They didn't work for me. But fortunately, I came upon another module by name TinyTeX, and that helped me to overcome the difficulty. Now, I could render the differential equations by using TinyTeX. So that's my experience. Then coming to the installation of the manning package itself, it's a simple one-line command, pip install manning, that's it. As I said earlier, pip is the Python package manager. I think you must be knowing package managers for different environments. You have got different package managers, like say for if you go to say web development, something like this, they have got something called as a Node.js environment. For Node.js environment, there is a package manager called as NPM, Node Package Manager. So you can use the Node Package Manager NPM for that particular activity. For Python, it is the pip. If you are using a Linux machine comes installed originally with the pip itself, that is Python and the pip. So you need not install any even Python also, but Python 3.8 is required for manning. 3.8, version 3.8, Python 3.8 is required. The earlier versions are not supported. And you can see the documentation corresponding to this manning at that particular docs.manning.community. At that particular website, you can see the documentation. The documentation is not very great. It's not very extensive. Sometimes it is very silent. But of course, that is not a big issue for experienced developers. If you are an experienced developer, you can easily understand it. But if you are a novice, you may feel certain difficulty to understand even the documentation. In which case, you can consult some experienced person to clarify your issues with the usage of the manning package. So that's about the installation and software. As I said earlier, you can use Windows machine or Linux or Mac. Any system is supported. Then how to create animations itself? The logic is very simple. We first create something called as a scene. A scene. To start with, of course, the scene is empty. Then we create elements. What I mean by element is all mathematical figures are elements. ఉదాహరణకి మీరు ఒక సర్కిల్ డ్రా చేశారనుకోండి. So circle is an element, it's an object. So we add that circle to the scene. And then we can do the whatever process we want to do that. Like that, there are hundreds of different types of objects that we can use for creating beautiful mathematical animations. Geometric objects are there, text objects are there, SVG you can add. I think you must be knowing SVG, scalable vector graphics, SVG, scalable vector graphics, I think. So SVG you can use, you can normal all the graphical objects, I say triangle, rectangle, Bezier curves you can use. Even at the top end, you can create a graph, and the graph itself can be added, like say a line graph, a curve graph, or a bar chart, a histogram. Those things can also be added. And once you add it, you want to do something with that particular object. That's exactly what we mean by animation. They are not still. The objects are not still. They are not frozen in time. So they have a behavior, something like say a circle which is growing. So growing is its behavior. So that itself we call it as the animation. So that animation we can specify. And once all these things are done, then we can create the animation file. So exactly the purpose of this particular manning package is to create that particular animation file. That is mostly MP4 video file. It will create MP4 video file, or it can create GIF files, or it can create If we are interested, a screenshot that also it can create. So the sequence is like this. First we create a scene, then we add the elements, we specify the element behavior, then we create that particular behavior or capture that particular behavior into a movie file. So that's the simple steps that are required. Then to do this particular one, you can use any code editor. My preferred code editor is Visual Studio Code, that is VS Code. If you are conversant with Atom, you can use Atom or you can use Sublime, like that. So students, I suggest using VS Code or Sublime. They are usually the industry standard code editors. But nowadays, VS Code is happening like anything. The popularity is rising day by day because of the conveniences or the attachments or the progression that is happening to the VS Code. So from student age itself, stage itself, if you are using, let's say, VS Code, then it's a very good thing. So you can demonstrate your use of VS Code to your employers. Okay, so try to learn VS Code. But I do not have any preference. My preference is VS Code. As per your preference, you can use any code editor. So creating a scene. Creating a scene is a simple creating a class from a parent class of the manim. So this particular one single statement class. So here the truss is the name of my own class, and scene is the class coming from the manim library or the module or the package. And the only thing that we need to do is we need to implement the function called as a construct. So we create a scene and implement the function by name construct. With that, we will be creating the scene. So there are only two sentences. Class, the name of your own class, and this is the parent class, the scene, and then the function. I think this is a Python code. You must be, if you are conversant with Python code, you will be understanding. Otherwise, don't bother. You can learn anytime. It takes only about 3 to 4 weeks to learn at least minimal level of Python programming. But of course, you must be conversant with some object-oriented programming also, how to use objects, all those things, that knowledge is also required. So this is how you create a scene. Then the elements. If you can see the screen, there are something like, say, LINE, capital LINE. That is the graphical object of line itself, like this. So I am adding a line for the purpose of creating a grid. And I am grouping all of them into a group for easy management. So this is how we create the objects. I think, do you know the constructors? If you know the object constructors, then that's the same syntax that we use here for creating the graphical or mathematical objects. Then how we specify the animation? The animation is specified very simply by using certain simple keyword. Like, say, when we use this particular function, say play, it means that it is going to animate something. So what it is going to animate? It is going to animate the process of writing a particular sentence, let's say. Just imagine yourself, you take a pen and write a sentence. I am a good boy or I am a beautiful girl. So you create that sentence letter by letter, correct? So if I call that as write, then what this particular command will do is the same thing. It will create the sentence letter by letter, but smoothly. That particular, so that itself we call as a animation. Just now we will see certain demo also, simple demo also, no problem. Like that. Then fade in, fade out. I think these part of fade in. ఏమీ లేకుండా కనపడేదాన్ని ఫేడ్ ఇన్ అంటారు, కనపడుతూ ఉండి మాయమైపోతే దాన్ని ఫేడ్ అవుట్ అంటారు. సో లైక్ దిస్. Then how to create the animation file itself? So we use this particular command called as a manim, M-A-N-I-M, the name of the Python source code, and then some command line flags. The command line flag that I am now using is a QL, that hyphen is there. That hyphen indicates the standard way of identifying the command line arguments. So that Q stands for quality and L stands for low. That means you can create your animation in 4 qualities: low, medium, high, and then 4K quality. Usually for development stages, we go for low quality so that we can test with what's happening with our animation. Once we are satisfied with our animation, then we can create a high resolution animation. Low quality is about 480 pixel wide, and whereas 4K is about 2880 pixel wide. I think you must be knowing all these particular standard values. So this is a screenshot of what I created in the past 1 week. So it demonstrates a particular, say, 2 wired support. If somebody is from mechanical or civil, then they will understand, or some old faculty who studied engineering mechanics of their part of studies, they will understand this. But understanding this is not very important, but the only thing is what it is doing, that is what animation it is doing, that is important here. But to coming to the domain, what it is doing, there are 2 wires. So one, there is a pink and there's a blue. So it is supporting a load, and the intention is to find the forces in these 2 wires. And the animation that I created is by creating this particular small triangle, which we call as the force triangle. We can learn about how the forces will be acting in these 2 particular wires. And for that, I created an animation. So let's first see that particular animation, and then I will tell something about the animation, and then later I throw up for the discussion if at all you want. So this animation, I am trying to start this. Please see, this will be just 1 minute. There's a fade out. There's a writing. There's a transformation. Again, writing a sentence. You see that it is growing from 0 to that length. Then you can see that the transformation happening from this one to this one. To demonstrate that, I need to draw a parallel line. So I'm drawing the parallel lines. Then I'm finding the intersection point. Then I'm closing the triangle with arrows on the other 2 sides also. So that's it. So it's a just 1 minute video. This is the code that I have written. This is written in using VS Code editor. There are about 150 lines, but with some blank lines, comments, all those deleted, it is around 120 lines. So it's not a big issue, but I took, because this is my first experiment with this package, I took around 6 hours. But next time when I want to do this, a similar problem, I may take 2 to 3 hours to produce a similar video. So because it's my first initial ingress into this particular mathematical animation, I took a little larger because I'm learning. So once I learn a little bit, become a little bit more proficient, then I may finish it off in one video in maybe 1 hour, 1 minute video in 1 hour. So that's it, folks. That's what I wanted to cover for you. And now I'm open for a discussion. Please ask me any questions.
Students and faculty, if you have any doubt, please interact.
Students, what I suggest is, if you are in first year, second year, you can learn Python and you can create the animations of the subject that you have learned. See, I'll show you one particular YouTube channel of that particular 3 blue, 1 brown. You will be amazed to see that this particular channel has got a total views of about 20 crores. 20 కోట్ల వ్యూస్ వచ్చాయండి. నాకు తెలిసి యూట్యూబ్ కూడా డబ్బు పే చేస్తుంది. ఐఎమ్ థింకింగ్ సింప్లీ, వెరీ సింప్లీ లైక్ దిస్. ఒక్క వ్యూకి ₹1 ఇచ్చినా కూడా నాకు 20 కోట్ల రూపాయలు వస్తాయి. నాకు తెలిసి నేను నా జీవితాంతం ఇంకా 20 కోట్ల రూపాయలు శాలరీ తీసుకోవాలా. My total salary would have been around 1 crore, I think, in 35 years. 35 సంవత్సరాల్లో నా శాలరీ ₹1 కోటి వచ్చింటదేమో. కానీ దిస్ మ్యాన్, స్టార్టింగ్ ఫ్రమ్ 2015, he must have earned crores of rupees just by doing some ప్రజాసేవ చేసి. So this is a possibility that students have. మీరు ఫస్ట్ ఇయర్లో, సెకండ్ ఇయర్లో మీకు కొంచెం టైం ఉంటుంది. ఈవెన్ ఎ లిటిల్ బిట్ ఇన్ టు థర్డ్ ఇయర్ ఆల్సో. లెర్న్ ఇట్ అండ్ ఎక్స్పెరిమెంట్ వాట్ యు డీస్. దెన్ ఆ తర్వాత ఏం చేయొచ్చు. సో ఫర్ ఎగ్జాంపుల్, మీకు బేసిక్ ఎలక్ట్రానిక్స్ అనుకోండి. బేసిక్ ఎలక్ట్రానిక్స్ మొత్తం ఒక 20, 30, 40 వీడియోస్లో మీరు ఎక్స్ప్లెయిన్ చేయొచ్చు. అట్లా 5-6 సబ్జెక్ట్స్ చేశారనుకోండి. Like that, you can create your own YouTube channel if you are interested. Okay, so that's what actually I'm expecting from students. I don't know whether my intention of conducting this particular one is, if any student is interested, I can guide them. I have time and I have energy to guide the students. And of course, if faculty are there, if faculty are there, 1 minute, sir, if faculty are there, I can also collaborate with them to create the course files, course animations, all those things. But I don't insist too much from the faculty side. But I'm interested to work with students. Sir, Narayan sir, adagandi.
Sir, circuit elements are available, sir? That
circuit elements ready-made ga undavu sir. Adi
ఓకే సార్.
ఏంటంటే మనము డ్రా చేసుకోవాలి. మీరు డ్రా చేసుకున్నారంటే అవన్నీ కూడా లైన్ ఎలిమెంట్స్, లేకపోతే సర్కిల్స్, పార్ట్ ఆఫ్ సర్కిల్, ఆర్క్ అట్లా ఉంటాయి కదా. అవన్నీ మెటిక్యులస్గా 1 by 1 మనము క్రియేట్ చేసుకోవాలి. క్రియేట్ చేసుకొని మనం అది వాడుకోవచ్చు. సో దిస్ ఈస్ హౌ ఫ్యాకల్టీ కెన్ కంట్రిబ్యూట్. ఇప్పుడు మనకి మానిమ్ ప్యాకేజ్ ఉంది కదా,
సార్
మానిమ్ ప్యాకేజ్ పైన ఒక సూపర్ ప్యాకేజ్ క్రియేట్ చేయొచ్చు. సే యూ కెన్ క్రియేట్ ఆల్ ఎలక్ట్రికల్ సర్క్యూట్ డయాగ్రమ్స్. సో మీకు ఒక ఫర్ ఎగ్జాంపుల్ ఒక ఇండక్టర్ ఫిగర్ కావాలి. సో యూ కెన్ క్రియేట్ ఎ క్లాస్ ఇండక్టర్ ఇట్ సెల్ఫ్. కొన్ని పారామీటర్స్ ఇచ్చేస్తే అది ఇండక్టర్ గీసి పెట్టేటట్టుగా ఈ ప్యాకేజ్ని ఎక్స్టెండ్ చేయొచ్చు. Actually, this package is open source. This is a GitHub package. If you can see on the screen, this is the GitHub package. You can download this total package and the faculty can extend this particular package.
Okay, sir.
Package ni extend చేసుకునేదానికి కూడా అవకాశం ఉంది. So that is what I suggest for the faculty. I think I answered you, Venkataraman.
Yes, sir. Yes, sir.
Okay, any faculty or students? At least.
So we have an opportunity to learn. Now, if you have any doubts, we can raise, students and faculty. Sir, go ahead, sir.
ఇంకా నాదేం లేదు సార్, ఎవరైనా నాతో కొలాబరేట్ చేయాలి అంటే నేను కొలాబరేట్ అవుతాను. నాకు తెలిసినంత విద్య వాళ్ళకి. నాకు ఇది నేర్చుకునేదానికి నాకు ఇప్పటికి 3 వారాలు పట్టింది సార్. సో నేను కొంచెం టైం ఇన్వెస్ట్ చేశాను. నా దగ్గరికి ఎవరైనా స్టూడెంట్స్ కానీ ఫ్యాకల్టీ కానీ వస్తే ఐ కెన్ ఆన్బోర్డ్ దెమ్ ఇన్ ½ an hour or 2 hours. See, that's how I wanted to help my students and my colleagues.
Yes, sir. Yes, sir. Thank you, sir. Thank you.
So most of us are telling thank you, but I'll be more pleased if at least 1 or 2 of you collaborate with me to do some reasonable work.
Yes, sir. All modulation techniques, so through the animation we are able to present, then it is easy to understand the students.
Yes, that's what see, KSRM itself can have a channel with these particular animation. So what the animation that he created is a simple video file without any soundtrack. ఆ తర్వాత సౌండ్ ట్రాక్ని మనం ఇన్స్టార్ట్ చేసుకోవచ్చు, వాయిస్ ఓవర్ చేసుకోవచ్చు, తర్వాత క్యాప్షనింగ్ చేసుకోవచ్చు. అదంతా ఇంకొక నెక్స్ట్ స్టేజ్ ఉంటుంది ఇది. సో దట్ స్టేజ్ ఐ డెంట్ కవర్ ఇట్ బికాస్ దట్ కమ్స్ అండర్ వీడియో ఎడిటింగ్. సో వీడియో ఎడిటింగ్ దట్స్ ఎ డిఫరెంట్ ఇష్యూ, బట్ దిస్ ఈస్ ద బేసిక్ రా స్ట్రీమ్ అనమాట. రా ఫుటేజ్ వస్తుంది దీంట్లో. ఈ రా ఫుటేజ్ తీసుకొని తర్వాత వీడియో ఎడిటింగ్ చేసుకొని తర్వాత పబ్లిష్ చేసుకోవచ్చు. సో దిస్ ఈస్ వాట్ ఐ థింక్ దట్ వీ కెన్ డూ.
Okay, sir. Thank you, sir. We are learning many things from you, sir.
Okay, sir.
So, okay.
Final call.
Yes, sir. Yes, sir.
Final call. Any students or faculty want to collaborate? Some question is there. Python is useful for mechanical, and how could you explain some on it? I didn't exactly understand this. Maybe Pramod, you're asking, Pramod Raju, whether mechanical students can learn Python. My argument is very simple line. See, programming, everyone has to learn, right from farmer to lawyer to doctor. I am not saying about engineer, because engineer is a de facto. Correct. So every engineer must know or must indulge in programming. So what programming language you use is your option. But the current trend, because of the so many opportunities that we have now, Python is the best language to learn for general purpose programming and multi-purpose also. C programming, as I tell you, అంటే నేను బ్రాడ్ స్టేట్మెంట్ ఇస్తాను, డోంట్ గెట్ అఫెండెడ్. యూస్లెస్ లాంగ్వేజ్ ఫర్ జనరల్ పబ్లిక్. C is or C++ is useless. It can do nothing. I'm telling on a general sense, we can do nothing with C language. But most of the computer science students learn C. That's a different aspect. They learn from a different perspective. That's a different issue. But everyone must learn Python. That's my argument. So if you are satisfied, Pramod, you can learn Python. Otherwise, just leave it. No issues involved.
Thank you, sir.
Okay, sir.
Valuable session, sir.
Okay.
So I thank all the students and faculty for your support. So please continue. So except Sunday, we will daily we will conduct these sessions. So we received an excellent response from the faculty. So okay. With
Alright,
this,
sir. Include students also.
Yes, sir. I invite sir students also. Yes, sir. Thank you, sir. So
Okay,
with this, I close that. Okay. Thank you, sir.
Okay. Thank you all of you.